to Jackson Square. We've been looking at the real number system. We've heard the song and we've seen the bags. So now let's get some notes to put down in our notebook. First, we have natural numbers. We said natural numbers are the numbers you naturally start counting on your hands and your feet. It doesn't mean that you stop at 20 because you ran out of fingers and toes. It just means they're whole numbers. You don't have 2.5 fingers, right? Nobody has half, a thirds, of quarters of fingers. You have 1, 2, 3 whole fingers. So natural numbers are counting numbers, also known as your counting numbers, and they start with 1 because when you're a little kid, you start learning 1 as your first number. Then from there, we know that natural numbers are a subset of whole numbers. So whole numbers are made up of your natural numbers plus 0 when you learn the concept of 0. So your whole numbers are your counting numbers plus 0. Then we have integers. So whole numbers are a subset of integers. Integers are your counting numbers plus their opposites. So let's see. There we go. So integers are whole numbers and their opposites. So that means positive 1, negative 1, positive 5, negative 5, positive 1,000,000, negative 1,000,000. They're opposites because they're the same distance away from each other, same distance away from 0 on the number line. And it includes 0 because we added 0 in when we got to whole numbers, right? So what an integer is not. The set of integers do not or does not include negative decimals or negative fractions. Just because it's negative doesn't mean it's an integer. It has to be a negative whole number, okay? Negative whole number. So that is a common misconception that kids have, is that it has to be any negative number. It's not any negative whole number, okay? Next, we have what's a rational number? So a rational number is not that definition, or this definition, or that definition. What happened to my definition for rational number? Oh, there it is. So a rational number is numbers that can be expressed as the ratio. And I'm sorry, let me edit that because that should not be an N. Rational numbers are numbers that can be represented as the ratio of two integers. So ratio means it can be written in fraction form, A out of B or A over B, where B is not equal to 0. Not equal. B cannot be 0, and we'll talk about that later, that you cannot divide anything by 0. If you try to put that in your calculator and divide something by 0, your calculator is going to say undefined because you can't do it. So I'm messing around here trying to get this here, but it should say B cannot equal 0, okay? Well, that's sideways. It's kind of rotated. It's not going to work. But B cannot equal 0. So B can't be 0. So what are some things that are rational numbers? Natural numbers are rational. Whole numbers are rational. Integers are rational. But what goes just in that rational realm? Negative decimals, negative fractions. And then there's some other things that go there. Repeating decimals and terminating decimals. So what's a repeating decimal? A repeating decimal does not stop, but it has a digit or digits that repeat. So it can be 0.33333 or 0.1212121212 or 0.1657, 1657, 1657, 1657. So it can be the same pattern. So it makes sense. It's rational. Rational means it makes sense. So it's rational. It doesn't come to an end, but it has a pattern that we can clearly see. So it's a repeating decimal. And terminating decimals are the opposite. They come to an end. They stop. They terminate. Like the Terminator, when he was coming, you didn't want him to come because he meant you were coming to an end. I'll be back. No, don't come back for me. So terminating decimals come to an end, like 100ths or 10,000ths or 125 thousandths. Those all come to an end. They don't repeat, they come to a stop. Then we have real numbers. We know that all numbers are real. Real numbers is the set of rational and irrational numbers. So in sixth grade math, we focus on the rational number side. And for seventh grade math, we focus on a little bit of irrational. So what is an irrational number? An irrational number is a number that does not come to an end and it doesn't have a pattern. So irrational numbers aren't as friendly as rational numbers are. So it does not stop and does not repeat. So rational numbers don't stop and they do not repeat. It cannot be written in the form of A over B. Does not stop and does not repeat. This is a irrational number. Sorry. Irrational numbers do not stop and do not repeat. So if we get a number that doesn't stop and it doesn't have a pattern, it is irrational. So if it's 0.125712371247125775532 blast off. Any of that, it just doesn't come to an end and it doesn't have a logical pattern that we can identify, it's irrational. So let's take a second and let's classify some numbers. So let's see, if I had 8/10, can I count 8/10 of a finger? No, it's not a whole number. It's not an integer because it's not whole. So this would be classified as rational only. Okay. What about 0? When I'm a little kid, do I understand the concept of 0? No. When I get to school, I understand the concept of 0. So 0 is a whole number. Negative 6 75/100ths. 74/100ths. It's a decimal and it's a negative decimal. Because it's a negative decimal, it's classified as rational only. What about 3/4? 3/4, I don't have 3/4 of a finger. It's not a whole number, so it wouldn't be natural, whole, or integer. So it's also classified as rational only. Fractions and decimals go in rational only. But just because something is in fractional form doesn't mean it can't be simplified. So always simplify. Try to simplify first. Simplify before you classify. Simplify before you classify. Hey, simplify before you classify. I say simplify before you. Hey. Oh, okay. All right. Here is a symbol. This is pi. Pi is the most famous irrational number. It does not repeat and it goes on forever. I'm going to attach a video down below with a little rap about irrational numbers, as well as a link to the site for Pi. Pi is a national math day that people celebrate. It's held on March 14th because Pi starts with 3.14. So you can look at how long Pi is. There's a page that has the first million digits of pi, and they do not repeat and it does not stop. -4. 4 is a whole number, but -4, I don't have -4 fingers. I could have -$4 because loan me $5. I mean, can I borrow something? All right, so -4 would be integer. That would be the first place you would classify it. So when you're classifying numbers, you want to put it in the first set that you would see it. So if it's a whole number like 2 would be a natural number. That's the first set I would see it. And then it would be included in all the subsets because a natural number is natural numbers make up whole numbers make up integers make up rational. So remember the cups, how they stack up. or remember the bags, how the natural numbers went inside the whole numbers and the whole numbers went inside the integers and the integers went inside the rational. So -4 would first start at integer. How about 8 halves? 8 halves sounds like a fraction, and I want to put it in rational, but I remember I was saying, hey, simplify before you classify. Hey, simplify before you classify. And if I try to simplify this, I know that 8 divided by 2 is 4. And I can clearly count that on my fingers. So this will be classified as a natural number because 8 divided by 2 is just 4. 0.33333333. It doesn't stop, but it clearly has a pattern, so it's a rational number. And then we have 152. It's a whole number. Can I count up to 152 on my fingers? Eventually, if I keep going, I can. So 152 would be classified as a natural number. So we've classified some numbers. We've got our definitions so we can help ourselves with classifying numbers. I hope this helps. See you next time.